Hello, everyone. I'm meteorologist Sean Sublett, and welcome to Across the Sky, our national Lee Enterprises weather podcast. Lee Enterprises has print and digital news operations in 77 locations across the country, including at my home base in Richmond, Virginia. I'm here with my meteorology co-hosts from Across the Sky, Joe Martucci in Atlantic City and Matt Hollander in Chicago. Our good friend Kirsten Lang in Tulsa, feeling a little under the weather, so she's not going to be able to join us today. So, gentlemen, tell us about how things are going in the big wide world out there. Joe, I know you've got a new studio working there in AC.
Yeah, we're coming to you from our new soundproof studio right here at the Press of Atlantic City. We opened up our new office last month, so I'm happy that this is an audio only podcast because you don't want to see the Home Depot boxes behind me right now. But there is a green screen and it is working, and we're doing videos on our website. So all is right in the world here at the Press of Atlantic City.
Matt, how are things in Chicago?
Oh, doing pretty good. Week started off quiet, but then another low pressure system coming through with a good old rain snow mix and trying to figure out when it's going to change over to snow and how much snow, all that fun. But, I was going back through some of our podcasts and looking at the numbers, and then I remembered we forgot to tell people our number 10 weather song of all time. Our top 10. If you haven't listened, go back and check out our top 10 weather songs of all time. And if you'll recall, we had a three-way tie for 10th place. So I went into the poll because we put a poll in the article that we sent out to see, we had everybody vote on the number 10 song. And so I've got the results. So
all right, drum roll, please.
So in third place, because it was a three-way tie, it was Riding the Storm Out with 18.2% of the vote. With 36.4% of the vote, it was Under the Boardwalk by the Drifters. And the winner, so our number 10 weather song, When the Levee Breaks by Led Zeppelin, it got 45.5% of the vote. So I'd say a pretty convincing winner. So that's number 10, When the Levee Breaks.
That is a victory for me because you all know how badly I campaigned for that song to make it into the top 10.
Yeah, I was a little disappointed. Riding the Storm Out was mine, and it came in last. So I guess it wasn't meant to be.
Oh, well.
Sean just knows. He's a magi of music.
I'm a classic rockhead. I am, no question about that. I'm of a certain age, as they say. But
27.
What's that?
27.
27? Yeah, right. Hang on. Okay, so anyway, on to the thing. It's been kind of warm here in the eastern United States since Christmas. I know you've had the warmth to deal with there, Joe, in Atlantic City. I know it hasn't been awfully warm in Chicago, but you've had the warm spells. But I think the big news today, and really all week, is that NOAA and NASA released their annual global temperature analysis for the year. And 2022 was the sixth warmest year on record for the NOAA calculations. NASA came in tied for fifth. So this really fits in with the overall climate trends we've seen. The 10 warmest years, the global record, have all come basically in the last 10 years. And really not a surprise, unfortunately. Greenhouse gases and fossil fuel burning continue to go on into the atmosphere. So with that, we want to talk to somebody from NASA today. So our guest is Dr. Nadya Vinogradova-Shiffer, who directs the Ocean Physics program at NASA headquarters in D.C., leading the development, launch, and scientific exploration of multiple NASA missions. She's a climate scientist and ocean physicist, got a PhD in ocean physics. She represents NASA at various national and international contexts, and her work can be found in more than 100 professional publications and scientific proceedings. And she has asked that we call her Nadya. So thank you so much for joining us from NASA on what I know is a very busy day.
Thanks, Sean. I'm happy to be here.
It's wonderful. And I love the background too. Hopefully we'll have a little video of this later on, the ocean currents in the background. I want to take advantage of your depth of knowledge in oceanography. There's nothing surprising for those who have been following the news about planetary warming. Today's announcement's just more evidence that the Earth continues to warm, and warming very quickly compared to geological timescales. So for us working in the weather business, we see it. But what kinds of things are going on in the ocean with the warming climate that we may not be aware of? And what are some of the repercussions for people living on the ground?
That's right. Indeed, our planet Earth continues to warm, and 2022 made this club of top 10 of hottest years on record. And as you know, Earth is a water planet. 2/3 of the planet is covered by the ocean, and it's really ocean that controls and modulates our weather and the climate. The ocean, just like the rest of the planet, has been warming up. Ocean is, taking for the Team Earth, and absorbing a tremendous amount of heat that we are trapping in the Earth system by accumulating extra energy and heat through the burning of the fossil fuel. And so ocean is, as I said, taking up for the team and absorbing all this extra heat and energy, and continuing to heat up and expanding, slowly taking over our land through sea level rise, or supplying more moisture and fueling hurricanes and other weather systems. So it is a really connected system, and all water, cycling through from ocean to land and back. And all of those, weather events that we see in the news that you guys are covering, they all originate in the ocean. So if you really want to know what's happening on land in terms of weather, you better go to the source, to your warehouse of moisture, which is our ocean, and observe and predict in order to have some lead time to know what's going to happen on land.
Yeah, before I turn it over to the other guys here for questions, I wanted to check on this one stat with you, that of the additional warming from greenhouse gases, approximately 90% of the warming is going into the oceans, the global oceans. Is that correct? And why is so much going into the oceans?
That's right. So, like when we talk about 1 degree of extra warming and temperature, 94% of global warming is going into the ocean. So, ocean has a very large heat capacity. So think about it, if you want to boil some tea, it takes a while for the kettle to boil, or if you're making pasta, whatever you boil. But at some point, your kettle is starting to boil. So it takes a while. It's longer than air, but at some point your temperature would boil. So the same with the ocean. It absorbs, it has a large heat capacity. So it takes in a lot of this extra heat, absorbs and redistribute. It saved humanity from the full impact of the atmospheric heating so far. And as you said, most of it, 94%, goes into the ocean. I would give you other numbers. I think over the decades, oceans accumulated hundreds of zettajoules of extra heat. And zettajoule is just such a big number, 10 to the 23 of joules. And for context, a zettajoule of energy, it's 10x larger than global energy consumptions of all human population today. And so an ocean accumulated hundreds of the zettajoules in the past 20-30 years. So really is saving humanity from the full impact of global warming. However, at some point, the kettle is going to boil, right? So what we're looking at in the climate community and with NASA assets is to see the tipping point at which the absorption of extra heat by the ocean slows down, and the ocean will start releasing this extra heat back to the atmosphere where it came from. And the rate of the atmospheric warming will change at this point. So this is one of the climate questions that we're interested to explore next.
Yeah, kind of piggybacking off of that, we do tend to forget about the oceans. So we're all, as humans, living on land, and the ocean covers up so much of the planet. So we absolutely can't forget that. And what strikes me as interesting this year, we had another top 10 warmest year, despite what happened in the Pacific, La Nina, below normal sea surface temperatures in the Pacific. And I'm wondering, though, at some point, we keep having these La Ninas, but is there going to come a point as the oceans continue to absorb more energy that we're not going to see La Nina form anymore below normal sea surface temperatures in the Pacific? And that's such a big driver on weather on land as well. Is there ever going to come a point where La Nina is going to cease to exist and it's just going to be average sea surface temperatures or above normal? Or is that something that we still don't know yet? But I just wonder what your thoughts on that about could there eventually reach a point where we don't see La Nina conditions?
So so those phenomena that you're referring, those are year-to-year oscillation in the climate system, in the atmospheric and ocean interaction patterns. So variation from year to year would always exist, like this chaos in the climate system that will persist, this internal variability or this chaos, this unpredictable, and would always exist. But what we have to think about it is the underlying secular trend, right? So even though those oscillation, annual variation extremes, those are stochastic noise, when you load the system, when you change the underlying trend, which is the increase in planetary heating, like the planet as a whole, it's get warmer. So that when you superimpose those oscillation like La Nina or El Nina, the response would be different. And just to tie into the record release, despite that we were still in a La Nina year, where we see a continued increase in the global temperature. So as we are kind of sunsetting from La Nina phase and going potentially into El Nina phase and the warmer tropical temperature, we anticipate that 23 would probably even push us a little bit higher on this ladder of climbing temperatures.
Let's just get into some of the numbers here. What was the global Earth temperature for the year? How much above average is it? And what are we using to compare it, to average? Are we using the classic 30-year 1991 to 2020 timeframe that we like to use in the weather world, or is this across a longer period of record when it comes to being above average? And then again, also the actual temperature that we saw on Earth as well.
Right. So the global average anomaly in 2022 is 1.1 degrees Celsius, which is close to 2 Fahrenheit. And we are using about more than 140-year record dating back to the late 19th century, 1800s, 1880 to be exact. And this anomalies global temperature compared to the long-term average from 1951 to 1980.
Got it.
And again, as Sean said in the beginning, this is tied for the fifth place.
Yep.
Kind of like competing with or tying with 15th in terms of anomalies. But still, if you think about it, it is this it's a club of 10 hottest years of record in the last 10 decades. So, the steady trend continues to be seen.
Yeah. And then when you dove into this data, when you've seen it, was there one stat that stuck out to you?
It stuck out to me that, if I guess we are still on the trajectory to have temperatures that the last time the Earth was that hot was more than 100,000 years ago. Like, if you think about it, we built all our lives, our economy, infrastructure around a different climate. Like, we built our houses, our energy storage facility close to the coast, our agricultural zone, everything, we built our lives around a climate that we actually never lived in. So as we're transitioning to a new climate, we would have to, rebuild our lives, the way we do business. So I guess that's kind of, it's a striking realization to me as a climate scientist, as we're monitoring what's happening with the planet, that what it means in a geological time frame, or what it means for humanity.
I think that's such a great point, Nadya, is that sometimes people can't make sense of what it actually means, but it goes well beyond just what it means for polar bears. We have to look at how we've designed our global economy, right, in terms of anything from infrastructure to agriculture. And going back to the oceans, sea level rise is, I think, one of the bigger things that a lot of the United States is going to have to deal with so much of the population along the coast. Can you speak to where sea level is rising a little more rapidly along the American coastline,
Right.
and what kinds of what kind of direct impacts we would see? I mean, in my mind, I think about things like coastal infrastructure being repeatedly inundated and just kind of wearing out from repeated inundation. But how fast? You know, we've got better satellite telemetry now over the past 30 years. How fast are the seas coming up?
You're right, Sean. This is so warmer planet means more water, higher volume of the Earth oceans. And we see that the sea level are rising now at a rate of 3 millimeter per year on average. And if millimeters are not very intuitive, I was just giving an example to my teenage son that if you measure that in gallons, because he said, well, what is it in gallons? And then I said, well, we are adding about 300 trillion of gallons of water every year into the ocean. And then he said, I don't get it. And then I said, well, if you line up those gallons like milk jars, when you make your cereal, it would cover the distance from Sun to Pluto and back. It's a lot of water. And then she's like, all right, that's a lot of water. I get it. So that means that, the oceans are, slowly taking over the land that we live on, right? And then you said a lot of economic centers are built on the coastal, in our coastal regions. Almost half of the world population lives near the coast, about 40 or 45%, right? This is where our energy storage facilities are. Like if you think, Galveston, Texas, our oil and gas storage facility, if they would become inundated and eventually destroyed, there is no energy for a sustained amount of time. Think about weather events and there is no electricity. How uncomfortable are we? Well, think of it as a collapse of our access to the energy storage facilities. Real estate, a lot of economic centers, a lot of hubs, coastal hubs, and this is military installation. A lot of those are national security issues. We're working with our partners at DoD and Navy, and this is a concern that a lot of our issues related to national security also impacted by the rising seas and erosion of the coastal and land systems. In terms of hotspots, New England is known as hotspots, both on land and coastal waters are slowly boiling up. I spent a lot of time in Boston, and again, just living there, you notice that everything is getting warmer. So we see about 2 or 3x sea level rise faster than the rest of the globe. Issues with sea level rise also concern in the southeast, Florida, Gulf Coast, which is further exacerbated by the sinking land. So yeah, extra volume because the planet is just warmer. Think about it. We are changing the physical state of our planet, almost everywhere across the planet. So large scale, planetary scale changes that we see.
And we saw above normal temperatures across a lot of the planet, but there were some locations in 2022 that saw below normal temperatures. So I'm curious, what areas were warming the most, were the most above normal, and what parts of the planet were the most below normal? Because there were a few places that were below normal temperatures. That's what you have to look at the global picture. But what were kind of the spots that really stood out as that are warming the fastest and maybe not warming as quickly?
Right. I think that the Northern Hemisphere predominantly exhibited warmer than normal or average temperatures. There were some regions in the Southern Hemisphere that do not show that rapid overwarming or even below average anomalies. But I think this hemispheric divide is pretty uniform. I would have to pull out the graphics to go into more details. But think about it, Northern Hemisphere versus the Arctic is off the chart. So high latitude and Arctic is off the chart. It's what we call Arctic amplification, where the warming is also compounded with the sea ice loss that exacerbate warming, and then all of that feedback loop, it's just, gets this amplification of the warming patterns in the Arctic. Arctic also has some highest rates of sea level rise in certain portions, buffer Jai, for example, and stuff like that. So yeah, think about how latitudes are just particularly hit by the warming of the planet.
Nadya, thank you very much. I know we've got to let you go here in just a minute or two, but for people wondering, is there anything one or two people can do on a local level to kind of help? Obviously, this is a big, big problem. Nobody fixes it alone. But if we're trying to empower people, what can we tell them to do to help?
Right. Well, NASA is a policy neutral agency. Our job is to observe and interpret, predict, and provide information that is useful for the public and decision makers. So we are not in business to tell people, turn your lights off and recycle. So you're putting me, in a tight spot here, Sean.
Well, I'm sorry. I apologize. I did not mean to put you into a tight spot.
Yes, but I think just a general awareness is a great first step.
Fair enough. Again, I understand NASA has things they need to take care of. So I apologize for putting you in a difficult position. That's something we'll take care of after we let you go. And we on that, we will let you go. So Dr. Vinogradova-Shiffer, thank you very much for joining us. We'll let you get back on the press junket today. And thanks again for all the work you do there at NASA, and have a great rest of the afternoon.
Thank you very much, guys. It was nice talking to you.
We're going to take a quick break, and we'll be right back on the Across the Sky podcast.
Make a difference. Relish a great work-life balance. Enjoy generous benefits and competitive pay. Go home each night feeling fulfilled by your work. Work for an employer of choice. Work for Blue Ridge Hospice. We're always looking to hire compassionate RNs, CNAs, or anyone interested in office or thrift shop work. We've been your not-for-profit community hospice since 1981. Visit our website for more information or to apply today at blueridgehospice.org. That's blueridgehospice.org. Blue Ridge Hospice is an equal opportunity employer.
Guys, it's every year we get this report from NASA and NOAA, and there are other agencies that do this annual temperature analysis. We hear about the folks at Berkeley Earth in California. The Japan Meteorological Agency does a version of this, and sometimes there are these teeny tiny nuanced differences, but they all basically say the same thing. And I think to Nadya's point is that the planet as we knew it, at least my age, 53 years old, is getting to be different. It may not be obvious from year to year, but those of us who have been around 40 or 50 years and have, this memory of the way things kind of used to be, it is different. It's not obvious from one year to the next, but when you go back and look at the data, and if you do talk to some of your grandparents, you're like, it just wasn't this warm as often as it used to be. And I think that's one of the things that we need to think about is how we've engineered the global economy, our infrastructure, our agriculture, all that stuff that's going to have to be revisited in a big way.
Yeah, even here in Jersey, obviously above average for 2022. Dave Robinson, who's the New Jersey state climatologist, he said 2022 was the 12th warmest since 1895 in Jersey here. I always like to, when it comes to what we're seeing with the earth and climate change, to bring it down to a level that people can see and understand. And for a lot of times, if you're along the shore, that has to do with coastal flooding. We've seen more coastal flooding events at the coast. We had 33 high tides in coastal flooding in Atlantic City. Some of that is just due to we keep building and building and building, and that means less water or more water that's going to run off into the bay. Some of it has to do with sea level rise as well, which is all tied into this warming climate. So, I always find it positive to talk to people in a way that they can understand, what does it mean that we're 1.1 degrees Celsius above average, with our global temperature. And usually it's well received because, climate change isn't a religion. You don't believe in it or not. There's facts and forecasts, and what you choose to do or not to do about it is where your beliefs come in.
And it's really important to look at the big picture because, there are little things you can look at and say, well, for example, for the US, this was only the 18th warmest year on record, 2022, whereas globally, it was the 6th warmest year on record. And the reason for that is actually there was a good chunk of the Midwest that actually saw below normal temperatures in 2022. And you say, wait a minute, what are you talking about below normal temperatures? And well, one of the things that we've been seeing is the old polar vortex coming down more often. One of the problems that you get with climate change is that the polar jet stream gets a little bit wobblier. And so the polar vortex can venture down across Canada and into the northern part of the US. And so you can get these cold temperatures like we saw right around Christmas time. And then, of course, that's when everybody starts saying global warming. What global warming? But then did you notice how quickly we warmed back up and how we really didn't stay cold? And when you look at the global picture, yeah, okay, parts of the Midwest were below normal, but look at all the places that saw above normal temperatures. So you do have to look at this globally. And then the other thing I hear people saying, it's like, well, this was only the 6th warmest year on record. Why aren't we getting warmer and warmer every year? Well, look at the last 10 years, and 9 of the warmest years on record have been in the last 10 years. So again, you're looking at the trend. There's going to be fluctuation regionally across the planet from year to year, but look at the big picture and it paints a very clear story.
Yeah. I mean, when we talk about year to year, we also have to remind people, when we go from spring to summer, from April to June, every day isn't warmer than the previous day. There are these fits and starts, but by the time you get to June, it's summer. All right. That's the same way with the warming climate. There may be one year that's a little bit cooler than the previous. But if you look at, as you said, Matt, over this 10, 20, 30-year time frame, it's clearly getting warmer. And, for me, I still get some fuss about, urban heat islands. And urban heat islands just make the situation worse for people living in cities. But back to what Nadya was talking about with Arctic amplification, there's not a lot of big cities in the Arctic. And the Arctic, which we heard Gavin Schmidt talk about on a conference call today, the director of the NASA Goddard Institute of Space Studies, the Arctic is warming 3.5 to 4 times faster than the global average. All right. And again, it's not like there's a bunch of cities up there. So it's one of these things that it's easy to just take a cold moment and go, oh, well, yeah, it's cold. But, we had that cold outbreak at Christmas. It got down to 8 degrees above zero here one night. But the record low is like -1. So even when we think, oh my heavens, this is really, really cold, it's still 7 or 8 degrees above record cold levels. What we think of as cold now is not the same level of cold as 50 and 60 years ago. And that's one of those things that's really hard because people's memories are short. And unless you've sat through or experienced that level of cold, it might be hard to really take all that in.
Yeah, it's just like how we're still setting record lows, yes, but we're setting record highs way more frequently than we're setting record lows. And you're absolutely right, Sean. We're defining a new normal now. And so now what we consider really cold, you look at the records and it's like, oh, actually it's been colder than this. And so it doesn't mean that we're not going to get cold anymore, but we're not going to get as cold and we're not going to be setting record lows as frequently. No, we're not going to stop setting record lows, at least in the short term. Maybe eventually there will come a time when we don't set any more record lows, but no, we're still going to set some record lows. But if you look at the frequency, we're going to set a lot more record highs. We have been and likely will continue to do so than we are going to set record lows.
Here's just to put a couple of numbers to what you said, Matt, looking at, and I'm looking at Atlantic City International Airport, but the trend's going to be generally the same everywhere. In the 2020s so far, about 80% of our records have been on the warmer side of those records, 20% on the lower side. This comes from a nifty program called ACES, which is run by NOAA.
Love that.
And pretty much we have been over 50% for the past couple of decades. The last time we were about 50-50 was the 1990s. And then we have been, below 50% with those record warm temperatures broken before that. So we've seen an increase on that, and a fairly, I'll say significant increase, since we were about 50%, 50-50 in the 90s.
Mhm.
Then by the 2000s, we were already 70-30, and now we're about 80-20. So, just put some numbers to what you were saying there, Matt.
Yeah. And plus, if you
I
think
know it's only
about,
for one location, but
yeah, if you think about, when you get a small increase in that average, it means you get a bigger increase in extremes. That's just a basic thing of statistics. But I'm working on a story today, and I found this nugget that in Virginia, statewide, the average temperature is up about 1.5 degrees since the end of the 19th century. But with the exception of 2014, every year in the last quarter century, Virginia has been warmer than the full 20th century average. So in other words, every year in the last 25 years, except for once, it's been warmer than average. So when we talk about, as you talked about, Matt, about a new normal, the normals are changing very rapidly. It's not like, oh, this is the new normal. I'm like, no, the normal is going to be different in 10 years, and it's going to be different again in 10 more years. The normals are changing. And it's not like you just wake up and climate change is here, boom, it continues to move. It is fluid. It is changeable. It is dynamic. So it's not like, oh, did it happen yet? No, it is happening, and it's going to continue to happen.
And Sean, following up, I know Nadya couldn't discuss it about what people can do to help, solve the problem. And again, I think that's kind of, I feel like we've been talking about this for so long, and there seems like there's been all these solutions pitched out, but there's really been no action. We haven't made progress just because I feel like it seems so overwhelming. And when you think about it yourself, it's like, I'm just one person. How am I going to make a difference? Well, remember that there are 8 billion people on the planet. So if we all did one little thing, multiply that by 8 billion, and that's going to have an impact. We just all have to start. We can't just sit back and be like, well, who's going to do it? Sitting back, we all have to just make a little effort. And the more people that make a little effort, it starts to add up. So you making individual effort can have an impact, and spreading the word and, talking to people about it. And so encouraging other people to make that little change, a little step, and it all adds up because there are 8 billion of us. And together we can have an impact, but we all have to take that step.
And talking about it does make a difference. Catherine Aho at the Nature Conservancy is a wonderful, wonderful scientist and science communicator on this issue. But just talking about it is a big, big help. Just bringing the topic out in the open. Okay, well, what can we do? You can do little things. You can do big things, depending on what you're prepared to do. Whatever you're capable of doing. Like even if it's I'm not going to drive, I'll drive a little bit less, or maybe I can get an electric car. Doesn't mean you have to get an electric car. Or maybe I make this little change. Maybe I buy a little less stuff. Maybe I recycle a little bit more. These things do add up. And again, one person doesn't fix it by themselves, but everything does ultimately sum up and add up.
Turning the lights off when you leave a room. That's what I'm guilty of, and I'm being better about it. I've like I'd say last year I've like noticed it's like, why am I leaving the light on in my bedroom? I'm not in there. Like, so when I leave the room, I turn the light off. It's one. If you're looking for little things, that's one thing. If there's a room that you're not in or nobody's in, go ahead and turn the lights off.
Yeah, shave a degree here or there off the thermostat if it's really not that big of a deal. Set it up a tiny bit higher in the summer or a tiny bit lower in the winter. I'm not going to suggest anybody go live in a cave, but take some little steps to save some energy and support areas that are moving away from fossil energy, whether that's coal, oil, or natural gas. I mean, natural gas doesn't burn as dirty as coal or oil, but at some point that's going to have to be phased out too. I mean, some people call it a bridge fuel, and we can go down a rabbit hole about that. I think there is room for optimism, but we have to stay on a path to keep this from really getting out of control. Joe, what do you got, buddy?
No, well, I was just thinking, is Matt's light thing, is that year 2 of your New Year's resolution? Can we consider it that?
Yes, I want to keep it going and be more consistent. So yeah, if everybody makes a New Year resolution to like try and reduce their carbon footprint, that could go a long way. And we talk about New Year's resolutions sometimes not working through. But if we all made a concerted effort at just doing little things, I mean, you don't have to radically change your life, but little things like turning the lights off when you leave a room or adjusting the thermostat a degree or two. Those little things it's going to take some big policies and at the government level changes to be made ultimately to, I think, have the biggest impact and have at the rate that we really need it to really slow down the rate at which we're warming. But if we all do a little bit on an individual level, it will have an impact and it's going to help, and it should not be overlooked and we shouldn't just take this as a situation where it's like, it's too much. I can't deal with it. I think that's the wrong approach. If we all do a little bit, it is a start. And then by keeping that conversation going, it'll start to have a trickle down effect. It'll reach the politicians who will then enact policies that'll even have a bigger impact. But we've got to start at the individual level.
Yeah, one of the other things that I think is counterintuitive about this whole thing is also snow, because some of the Great Lakes stay open, meaning they don't get covered in ice as fast. When cold air does race across them, they could actually produce more snow than they had in the past. And we're starting to run out of time here, but I think that's a good segue to our guest next week. Joe, I know you've been in touch with our buddy there in Buffalo, New York, who has had just a phenomenal amount of snow this winter. And look, we're not going to say, because of climate change, Buffalo got more snow. Not necessarily, but it is one of those longer term data points that you really need to monitor, because as the lakes stay open or ice free longer, and you just have to drag some cold air across the lakes, which is easy to do in December and January, you're going to get snow. So can you give us a little preview on, did you talk to Don a little bit?
I did, yes. Talked to Don Paul. He is a Buffalo legend, a New Jersey native, a Rutgers guy. So him and I got a lot in common here. But he works with the Buffalo News. That's one of our sister publications. Shout out if you're listening from Buffalo. He does some weather writing for us. He's our meteorological stepbrother, maybe we'll call it. He's certainly within our Lee Enterprises ecosystem, but he's going to talk to us about the Buffalo blizzard that just happened in December, along with that big event that happened in November as well. Here we're going to talk about both of them, and we're going to put it in context with the 1977 blizzard in Buffalo, because for many in that area, people are going back and forth about which one's more impactful, 77 or what just happened in December. It was truly historic in December. There were unfortunately lives lost. But Don's going to hop on to talk to us all about that. So we're looking forward to having him on Monday. And then Sean and Matt, I think we're pretty much booked up with guests through the rest of January.
Yeah. I've got to get in touch with my old buddy Joe Murgo. We're going to talk about Groundhog Day. But yeah, I'm really looking forward to hear from Don Paul. He is, as you like to say, Joe, the OG of Buffalo weather. With that, we're going to go ahead and shut it down for this week. But we are looking forward to talking to Don Paul from Buffalo about all the snow they've had so far this season. So for my buddy Joe Martucci there in Atlantic City and Matt Hollander in Chicago, and we hope to have Kirsten Lang from Tulsa back next week. Have a great week, and we'll see you next time on the Across the Sky podcast. Groovy.
Spring is here. That means it's time to get out and get on the road in my all-new 2023 Honda CR-V Hybrid. You heard right. The Honda CR-V is available in a hybrid model. I'm pretty excited about this. I've been waiting for the right time to make the switch to a hybrid, and I'm so glad I did. Not only am I greener, I can take on any terrain with the available real-time all-wheel drive and sport mode. Make a move to one of the most electrifying Honda vehicles yet. Find your CR-V Hybrid at your local Honda dealer today.